Okay, so here we go on Unit 10, or what I'm calling, or Section, Chapter 10. This is actually going to be Unit 9 notes. So Unit 9 notes and circles. So first section, a circle is a set of all points in a plane that are equidistant from a given point called the center. So what they're saying is you have the center of the circle, and then you have a point up here. Maybe that's 2 centimeters away, and maybe this one's 2, and this one's 2, and this one's 2. And then all together, all those distances of 2 make a circle. So this wasn't the best circle ever, but this is 2 centimeters. Any point on this circle would be 2 centimeters, which creates your radius. Your radius goes from, which is the next one, the radius goes from the center of a circle to anywhere on the outside of the circle. That is your radius, and it will always be the same measurement. Okay? Diameter goes through the center of the circle to both sides. So it touches a side, goes through the center, and touches the other side, and it has to be a line. So your diameter is 2 of your radii. So diameter equals 2 of your radiuses. Then we have a secant. A segment that contains a chord, we have a chord next if I can read in order. Chord is a segment whose endpoints are on a circle. So we have this. This would be a chord. Its endpoints are on the circle, but it does not go through the center of the circle, because if it went through the center of the circle, we'd have to call it a diameter. Okay? And then we have a secant. A secant is a segment that contains a chord and is exactly one endpoint on the outside of a circle. So a secant, we have our circle. A secant goes through, it's a line, so it's never ending. Whereas a chord stops on the endpoints, a secant is a line goes through. So a chord can be contained inside a secant. So I could actually have a line here and say the chord is from endpoint or from point on the circle to point on the circle, but the secant actually goes through the circle and continues on. A tangent is a line in a plane of a circle that intersects at exactly one point. So that would have to, let's say I have a circle, let's say there's a point on that circle. The tangent intersects just at one point. Now it may look like this tangent intersects at multiple points, but a tangent just intersects at one point. Theorem 10.1, in a plane a line is a tangent to a circle if and only if the line is perpendicular to the radius. So if we think here's my tangent that I just drew, right? We have our center of our circle. And if I draw the radius in, right? So there's the radius from the outside of the circle to the center. That tangent line will always be perpendicular to the radius. Always, always, always. So then we have some right triangles that we may have. And so you may have to do some math on that. That's what this theorem is saying. And then 10.2 says, tangent segments from a common external point are congruent. So what they're saying is, if I'm going from this point T, and I am going this way at this angle, it's going to hit at a point that's tangent. So this is a tangent line. This is a tangent line because they hit at one point. What's going to happen is this piece is always going to be equal to this piece. Okay? Match the notation with the term that best describes it. So what I want for you to do is I want you to pause me and I want you to try to match these up according to what we know and what we just learned. Okay? I'm not going to go in order, so unpause me when you're done. I'm not going to go in order. I'm just going to go with where I know. I know that that point C is the center of a circle. Okay? Point G is also. Okay, so I've used that. A chord, remember what a chord is. So D is not a chord. FH is not a chord because FH is a line. A chord has endpoints. C to D is not a chord. C to D is actually the radius, so I can put C to D as the radius here, so I've used that. A to B, and it's not saying line AB, it's saying segment AB. So that's what we would want for the chord, so that is our chord. So that is B. It ends on the endpoints because we're not saying it's a line, we're saying, so down here we have line AB. Line AB would be our secant. That is H, our secant. Because remember, a secant is a line that has both endpoints on the circle, or both points. It hits the circle in 2 places. But a chord is just a segment. So this is the difference between a segment right here and a line right here. A to D goes through the center and it goes from end to end. So that would be a diameter. Okay. D to E D to E. Okay, so we have D to E and F to H. So this guy and this guy. And what I have left here is a common external tangent and common internal. Common means that it's on two circles, two or more circles. External means it's on the outside. Internal means it goes through the center of the circles, or through the middle of them, because it doesn't go inside. So this one right here would be, it's a tangent to this circle because it hits it at point D. It's a tangent to this circle, so it hits at point E. So that's a common tangent because it hits two circles. But this is on the outside. It's external. It's not going through the center of the two circles. So that would be a common external tangent. So D to E is a common external tangent. So I'd use this. Common internal tangent would be it goes in between. So it hits at one point F, hits at one point H. It goes in between the two circles, so that would be internal. So that's line FH. So that is G. And then D right here, D is the point at which this tangent hits that line. So that is the point of tangency. So that would be E up here. All right, next page. Use circle P to draw the part of the circle described in the answer to the question. So draw diameter AB. So diameter goes all the way through. It hits the circle. I'm going to call that A. I'm going to call that B. Draw tangent line CB. So it's going through B. So tangent just hits at one point. It's going to hit at point B because we already have point B on there. And I'm just going to put point C somewhere on here. Chord DB. So chord has 2 points on the circle. And the 2 points are D and B. And B was already there, so I had to use that one. Draw a secant through point A. A secant through point A. So it just has to be a line, not a chord, but a line that goes through the circle at 2 points. So it's going through point A, and then I can name that point. Let's name it, what's letter we haven't used? E we haven't used. What is the name of the radius of the figure? What is a name? So one of the radii is here. A to B was a diameter, so A to P could be a radius, or P to B could be a radius. Those are the two that we already have on there. Tell how many common tangents the circles have and draw them. Common tangents, remember, they can hit the circles at one point. So I can draw a common tangent there because it hits there and there. I could draw a common tangent here that hits here and here. Okay? I couldn't go this way because it wouldn't hit that smaller one, so this has two. Now, if I were going to draw a common tangent here, remember it hits at one point. There's no way I could hit the inner circle at one point and the outer circle at just one point, so this one has 0. Here, this one's kind of tricky. It actually goes diagonal. It's there and there. It's there and there. Ooh, there's actually more than that. We can also go down like this, and we can go down like this. So this one actually has 4 common tangents. I want for you to try 17, 18, 19 on your own, so pause me, unpause me when you are done. Okay, so 17 was 3, so my circles are not the greatest, but hopefully you can get the idea. I put 2 circles right next to one another because they will have a common tangent of the point at which they intersect at. There's a line that I could put there. And the line that goes on the top that intersects at both circles and the line at the bottom that intersects at both circles at one point. 2, I just used the same one from above because there was 2 there, so there's 2 here. 19 is 1. So the only way to draw that is to have a circle and then a circle inside, but they have to have this joining point right there. Okay? In the diagram, BC is the radius of circle C. Determine whether B is a tangent to circle. Explain your reasoning. So if it's a tangent to the circle, this would have to be a 90-degree angle. In order for that to be a 90-degree angle, Pythagorean theorem would have to work. So your a squared plus your b squared would have to equal your c squared. So I'd have to be able to do 3 squared plus 4 squared to equal 5 squared. 3 squared is 9. 4 squared is 16. That should equal 25, and it does. So this is yes, it's a tangent. And then this one, again, this would have to be a 90-degree angle if it is a tangent line, meaning that it only hits the circle once. And if that's true, then it would have to be 3 squared plus 6 squared would have to equal 7 squared. 3 squared is 9, 6 squared is 36, 7 squared is 49. 9 plus 36 is 45. 45 does not equal 49, so this is not a tangent. Meaning it would actually be a secant, because what's going to happen there is it's actually going to have to go through the circle, so it's going to hit at more than one point. Okay. All right, one more page, guys. Almost there. In the diagram, AB is a tangent to circle C at point B. Find the radius of the circle. So this one, again, would be 4 squared plus r squared should equal r plus 2 squared. Okay, so this you have to remember back to algebra because r plus 2 squared really means to do r plus 2 times r plus 2. Then you have to FOIL. First, r times r is r squared. R times 2 is 2r. 2 times r is 2r. 2 times 2 is 4. That should equal, I'm just going to bring this down, 16 plus r squared. Okay, so hopefully that made sense so far. So all I did was a squared plus b squared equals c squared, but c is r plus 2, which means r plus 2 times r plus 2. Combine your middle two like terms, that's 4r. So I get 16 plus r squared equals r squared plus 4r plus 4. I'm going to subtract r squared from both sides so they actually cancel. And I'm going to start solving for r. So what I have there is 16 equals 4r plus 4. I'm going to subtract 4 from both sides, so I get 12 equals 4r. And then I'm going to divide both sides by 4, so I get r equals 3, and they wanted us to find the radius. There's the radius. Go ahead and pause me and try 23 on your own. Unpause me when you are done. Okay, so on this one we get a squared plus b squared, so r squared plus 12 squared equals r plus 8 squared. That's our c squared. So again, we have to kind of solve it like we did the last one. So r plus 8 squared really means to do r plus 8 times r plus 8. You FOIL r times 8, 8 times r, and 8 times 8. So I get r squared plus 144 equals r squared plus 8r plus 8r plus 64. Combine your middle like terms. It gives me 16r. Okay. I'm going to subtract r squared from both sides, so that actually cancels out those r squares. I'm left with 144 equals 16r plus 64. I'm going to subtract 64 from both sides, and I get 80 equals 16r. Divide by 16, and I get r equals 5. All right, two more. JK is a tangent to circle A, or circle L at K, and JM is a tangent to the circle L at M. If you notice, we are naming circles by its center point. Okay. What we said on the other side is if we have a tangent line that both start at the same point, those two tangent lines are congruent. So to do that, I would say 3x is going to be equal to x plus 12. I subtract x from both sides, so I get 2x equals 12. So x equals 6. Same idea here. This is equal to this. So 5x minus 4 equals 2x plus 2. I'm going to subtract 2x from both sides, so I get 3x. And I'm going to add 4 to both sides to get 6, so I get x equals 2. Okay, the homework, you're going to have 2 homework assignments. So you're going to have 9.1 in Schoology, but then you're also going to have, we're calling this is really Unit 10, so this 10.1 also in the supplemental packet. So make sure to do this. There will be a Schoology assignment asking for the answers from this, and then also the regular Schoology assignment. All right, thanks, guys.